And my speciality is this one, that we can burn something like wood or crop or grass, some other grass, any material can be burned. It could be something which burns naturally, but it could also be something which we burn for household heating, like rockwood in Germany is very popular. But we can also do this to study the effect of wildfires, because we collect the smoke, we dilute it and put it in this chamber, and then we can mimic the chemistry of such biomass burning. Yeah. That's also part of the chamber, and this could also be assessed. So if we say that could be interesting, I have seen many fires in the agricultural areas here. In many countries very complicated. And for the chamber, I brought a little video. Let's look at it. So here we go with our chamber laboratory to show you the chamber. This comment is in German, so I'm speaking over it. Okay. And this is all the measurement equipment here. Yeah, this is the particle size, and all the measurement system go to the chambers just vertically with transfer tubes. So all on the ground level has some machinery that measures up to the chamber. Many of these powers are spectrometers which sample in real time from the chamber. It's another spectrometer. It's a chemical ionization spectrometer. It's a trial reactor, just a tube of 1 cubic meter. This is a gas phase envelope. Now, and we go through the bottom of the chamber into the outside. This is the aerosol generator. Air filling. Because the basic air background must be clean. Here gives us the next spectrum. Particles. Also as a cockpit, we control all the parameters from the chamber, temperature, humidity, NC trace. So two chambers, 80 cubic meters each. Okay, so that was the chamber to show you the facility, and this would be something on the gas phase, the degree chemistry. I don't want to go into the detail. It's an aqueous laboratory. We are big fans of photochemistry to produce radicals, and then study the radical reactions. Atmospheric chemistry is pretty much radical chemistry. And the students this week are doing very nice to dig into it. They had a very simple chemistry background, so it was very, very good experience. Okay, and then we can imagine a lot of analytical equipment because we need to analyze what's in the field, what is there. But I'm always saying that we have all these analyzers, we can also, with equal right, just give them chamber samples. For the analytical chemistry, it doesn't matter if the sample comes from outside or it comes from the chamber. It's is the same. Yeah. So all our laboratories with the samples as a chamber by morphine. Yeah. And then the third complex would be the modeling. And over the many years we worked on this modeling system. And the idea was we want to describe this microspace chemistry for different application cases. And like we can do here halogen chemistry for ocean atmosphere, the interaction EP and SME, like for polluted air we can do aromatics chemistry. We can do photosynthesizer, we can do biomass burning or isoprene chemistry from vegetation emissions. So, and this is also open, everybody can contact us and say, okay, you help us with understanding some biogenic VOC emissions. We can use it. This is like open source, and also the model is not protected or something everybody can apply. And as I said, the speciality of this model is distinguishing gas phase and particle phase. And then the good thing is we can do a lot of numerical analysis. For example, to explain field measurement, we can analyze like zinc source. This is a period which comes from the Schlüter experiment where there is a cloud. And you can see this is aerosol condition, and positive values is production of OH radical in the particles. And this is the cloud phase in the middle, and this down here is the OH consumption. So we can really see, say, this thing is produced, or this reaction is producing the OH in the particles, and this green would be the Fenton reaction, just the interaction of iron 2 and argent peroxide. Yeah? So if you want, the model is very good analysis tool. It can enable us to go beyond just measuring. You can measure in the field and submit paper, and it will probably go through, right? It's okay. But if you measure and you model it, you take it to a new level of understanding. It's one step better. You can go to one better journey. Yeah? Okay. And now I could walk you through some special system, but maybe I just want to mention very quickly that we actually did something on wood burning. So we have some expertise in the field, and I cannot present all of this, but you can have a quick look here. And then the second topic is virus is also transmitted by particles, and also bacteria can be transmitted by particles. So we call this pathogens. This is a topic for the future. This was triggered a lot by the COVID-19 pandemic. You can imagine, right? And this is something where we worked a lot with the chamber actually, and we can really say a little bit. And then one more field would be micro and nanoplastics, which is discussed much, but it affects also us for the atmosphere, because you find the micro and nanoplastics on very remote places where you cannot go and dump your Coca-Cola bottle, but the only way to get microplastics there is through the atmosphere. And that's a proof that we have dispersed micro and nanoplastics worldwide by means of atmospheric transport. We have these three complexes. And it come to an end actually. Areas and a few special cases, but shortly, I didn't want to elaborate on each one for 15 minutes. And I think we do some classical atmospheric work, but we are also entering into a little bit new things. like virus is rather new, virus transmission, or also micro nanoplastic is also rather new. Combustion aerosols, the effect of wood burning, crop burning on air quality, it's a classic, but still needs to be done for certain target areas, like maybe here. Yeah. And so I would like to thank you for your attention.
Thank you very much, Professor Hama. Thank you. We are going to be having questions that he is going to react to. Before then, it is just important that I recognize personalities within this facility. First of all, I would like to recognize the woman, the magical Professor Yahweh, who is more or less our host here. Welcome. This woman built this facility in 6 months. Isn't she magical? And we have Professor E.G. Olumayede from the Department of Chemistry. We also have Professor Bolai from the Department of Mathematics. And we have the head of Department of Environmental Management and Toxicology, Dr. Adeju. And we have also eminent personalities whose names I'll be able to mention, and that is everyone here. Thank you. We are listening to Professor Emma, and while he was presenting, I saw that he more or less showed us a lot of areas where he feels the code is instituted of assistance or importance to our different areas of research. Initially, I thought it was all chemistry, but later I saw modeling, I saw biochemistry, I saw microbiology, although I haven't seen geophysics anymore. But I believe those of us here will have some questions to ask people. Specifically on how, like I said, they have come with their hands open. And the whole news is us to take advantage of their presence here, strike that connection, and ensure that they don't just come and go. You have to take something. You have to initiate something in this form. And like I said, they are ready to assist. So if you have questions that you want to ask, I would nominate that you write them, and I will read them out and he would respond to them. We can make that snappy, please. One more presentation. Do we have 2 minutes to do that? Okay. And you can also speak. Prof, you want to say something? All right. So once Professor Olumayede to speak. Thank you.
Good afternoon, Prof. Thank you very much. Professor Wadega, thank you very much. Thanks for coming. Prof has actually given us a very wonderful presentation. And I'm happy this afternoon that I think this thing is open for most of our works. When it comes to environmental, atmospheric chemistry, people see it as chemistry per se, but you have actually break it down. Chemical analysis is very important there, but still other areas are also important. My problem from my experience in Nigeria is that we have a lot of things to attend to, especially when it comes to atmospheric or atmospheric problem. Like you talk about the burning. Yeah. We have a lot of polyaromatic hydrocarbons available in our environment and which are reacting with hydroxides and other precursors to generate a lot. I work on volatile organic compounds in my PhD, and I realized that we have a lot that we have not been able to even profile in our environment, and they are reacting. So, but the bottom line of our problem here in let me say in Africa is the sampling. And in your own area, you have moved beyond sampling problem. You have moved to sampling with the modern, the emerging trend. Then, for us in the academics, we are interested in modeling most of these things. But before we can talk of modeling, we have to have the laboratory experience. Like presently, I know of a friend who is working on most of these pesticides we have in the environment. And he wants to model those, their degradation. But the problem of the chamber, I was so happy when you are introducing the chambers. So I wish we can partner in that area so that we can, most of these problems we have, we go along with to solve the problem. Because I'm interested in that aspect. Thank you.
Thank you very much. You want to react to that?
Yeah. Just shortly, you are very much invited for collaboration, as I said. We can help a little bit in the field assessment, but we can also help in the basics. When we say, before you want to go modeling, you need to have the basic parameters. Because we have with our model, we have quite a good overview, and we can even generate some more reaction rate constants, let's say, when you need it. Like I said, we can do some of our own lab measurements. How is this pH functionalized, for example? We could study this and plug it in the model. Maybe this is some options which I see. The biomass burning and the emission of the pHs is ultra important. It will be a main reason. It could be that the European Union will forbid blockwood burning for households because of this. This is currently discussed. It is a little bit critical because it's a cheap fuel, but the danger for health is really high. That would be based on this research. So PAAs in PAAs emission from biomass burning very important.
Even organic emission, the problem around the application, you can see around us here, we have a lot of different pieces of trees emitting organic volatile organic compounds around, and they are also reacting.
Thank you very much. There is a question here. The person is asking if postgraduate students can send samples to your institute for analysis such as spectroscopy and tribology. The major challenge we have in Nigeria is that when students are doing projects, they send samples abroad and usually exorbitant, and they may not be able to afford it. Within the confines or within this collaboration, can we send our samples at affordable rates, and perhaps can our students come for benchmark?
Yes, the answer is yes.
Very simple.
If you ask that question, you just got the answer. It is yes. Then it is left for you to make that yes work. Thank you. Another question? Do we have other questions? You just got a yes. You don't know whether your question will also have a yes.
Yes, thank you for this opportunity. And just like my said earlier, that we were looking for juveniles. I'm a geologist, and I'm hearing about atmospheric chemistry, very important to our planet. As a geologist, I believe the atmosphere, the hygrosphere, and the lithosphere interact. So, sir, I want to ask, in the course of your career, have you done any research in collaboration with geologists? Yes, I just want to ask.
Can't remember.
Yeah, I mentioned marine chemistry, but this is like oceanography. There we have collaboration. With geologists, there could be some, if it goes in the direction of mobilization of mineral gas. So that could be a topic. Like, how do you get the mineral gas dispersed? So that could be a topic. Yeah. And for this, cutting a photo is.
Thank you, Prof. Do we have other questions? Or you have a question? Okay. Okay, mommy. Let me.
For a wonderful presentation. All I can say here is an interdisciplinary research and the beautiful facilities that have been shown that you have in your laboratory in Germany. And I was asking some of my colleagues there, it's on the aerosols, the nanoparticles, and the viruses that are captured, especially their role in the atmosphere, particularly in disease causing when it goes into the lungs and all of that. And perhaps interaction in climate change, manipulation, which was the bane of COVID-19. The rapid spreading of that can easily affect everyone. So we would like to know the interrelationship of your research in the area of the atmospheric chemicals versus what is the interrelationship between this aerosol bacteria and viruses and the chemical component of the atmosphere, so that we find out the link between both. They're not suspended just by themselves alone. There must be some form of interactions between these chemical particles and the viruses in the atmosphere. So we're interested in the nanoparticles that are also in the atmosphere. How we can work on that and keep the atmosphere clear and give clean air to populace.
You mentioned some very important things. In the aerosol particles, they exist in some layer, which is like a gel-like structure. But there's also a lot of active chemical ingredients in this. Like you have, for example, radicals which would damage. And on the other hand, you have ingredients which also protect the ions from the attack of the chemical. So this interaction of virus, maybe even bacteria, with the chemical environment, very important. And the other topic, nanoparticles, this is a topic on its own, and we have some methods to sample them and do chemical analysis also in rather small size range, 50 to 140 nanometer. So it's a little bit extended over 100 nanometer, but for these particles we can sample and analyze. And so addressing these two, there's a possibility. The virus thing was, of course, triggered by the pandemic, and we tried to keep it up in Germany. But I would say it was politically decided that the pandemic finished, and so the funding support also finished. So it's very difficult to keep that up. We wanted to make a distribution. Yeah, I can imagine. It would be important to maintain some activities because I have recently given a talk and I was saying there will probably be the next pandemic, but we just don't know when it will be. So it would be clever to prepare a little bit and know what's going on. When the pandemic started, Germany was so unprepared that I imported protection masks from China to help at our local virology hospital because they had no protective masks, you know. So there was nothing. Okay, so you are totally right.
Thank you, Paul. Okay. Because of our time, we still have one lecture. To announce to you that this conversation continues, the university is going to create a specialized email for our visitors, such that once they see that email, they know that it is customized for free. They know that it is purely free matter. So when that email is ready, we'll make it available. You can ask your questions and some important information that you may want to pass through. You may go through the head of the department of chemistry, that's Dr. Faboy. That will give you better credence to introducing you to our visitors. Thank you very much. Now, I would also request that Professor Dr. Wadega Foma stand and remain standing. He is also an abridged citation. With his permission, I will just skim through the citation. Professor Dr. Fonga is the group leader of the Continental and Mineral Dust Aerosols Research at Atmospheric Chemistry Department of Leibniz Institute of Atmospheric Research, Leibniz. His doctoral research was carried out at the NHO's Center for Environmental Research, UFZ, and Institute of Experimental Physics of the University of Germany. In 2024, he became an associate professor in environmental health and air quality affiliate professor, and air quality at Mohammed VI Polytechnic University, Ben Gurion, Morocco. He had a brief research stay as visiting professor at Global Research and Training Center, Global Namibia in 2019. He had his postdoc at the Leibniz Institute for Tropospheric Research, Atmospheric Chemistry Department, Leipzig, Germany. Between 2010 and 2012, he was at the National Institute of Meteorology and Geophysics, Cape Verde, as a visiting research associate. He was a research fellow in the Department of Environmental Engineering and Bold Center for Environmental Research, UFZ, Leipzig, Germany. Since 2021, he has maintained a lectureship position at the West African Science Service Center on Climate Change and Adapted Land Use, WASCAL Graduate Program in Climate Change and Marine Sciences at Atlantic Technical University, Cape Verde. From 2024 to date, he has been a member of faculty at the African Research Center on Air Quality and Climate at Mohammed VI Polytechnic University, Ben Gurion, Morocco. In terms of scholarship, Professor Dr. Fonga won the Leibniz competition in the year 2020 and is also a recipient of the DAAD Fellowship. He has supervised one postdoc and has one ongoing. He has successfully supervised 3 PhD projects and an ongoing one. Professor Fomba was the co-organizer of the first international conference on air quality in Africa, and he was the organizer of the Atmospheric and Marine Sciences Summer School, Cape Verde. Distinguished ladies and gentlemen, I present to you Professor Dr. Udinga Fomba for his presentation. Thank you.
Thank you. Give me a while to put my slides on. So, thank you very much for the very interesting introduction. I must admit it's the first time that I've been introduced to such an audience, and it's a privilege for me to be here to give you some insights into what would be interesting for you and a headway towards collaboration. Before I continue, I would like to thank Professor Herman, because for every collaboration there must be a vision behind it. And he's not only my boss, but he's a visionary. Because by the time I started working with him, 2009, he had a vision for collaboration in Africa, which most of his peers did not see coming. And thanks today, because of his vision, we are here today. So, during my tenure with him, I've learned a couple of things. And as my fellow colleague, Dr. Fobia, was with us, when we were about to come here, he said it would be necessary or important for me to give some insight from my experience, what could be a strategy for strengthening international collaboration and equitable partnership. So I looked up what's the current landscape in research in Africa, what has been happening globally from north to south, and I found some interesting insights that indeed there is movement and dynamics in research in Africa. Over the last 10, 15 years, the amount of publications from Africa just in the field of sciences, natural sciences, doubled. In sub-Saharan Africa, there has been an increase of 0.37, around 0.3%. That's quite significant because we are talking about tens of thousands of publications. It's still not one to mention that is insignificant to global output, but significant in the steps that has been taken to make this happen. Within Africa, we need to understand there are certain things that could concern us more. And indeed, we see in the results that tropical medicines is where most of the publications in Africa are diverse, which is quite good. But there are other aspects that in Africa people are waking up. That is chemistry, engineering, physics, material sciences. And among them, I'm happy to say Nigeria is among the top 4 of the countries that is participating. But there is still a lot to be done. So, we have seen an increase in 0.3%. Is that enough? Of course not enough. So, that's why in research institutions, we must develop strategies how to go beyond that. And strategies that should not limit within departments, but strategies that should go for institutions. And now I will just try to give you some insights how such a strategy can be. it's not limited to atmospheric chemistry. So, be you a geologist or a mathematician, it could be something that we could all look into it. When I looked into the literature, I realized international collaboration is the key to the top 2 leading universities or countries in the world. That's Egypt and that's South Africa. Those 2 are at the high end. Their productivity is 3 to 4 times that of Nigeria. And they make up, just the 2 of them make up more than 60% of the productivity of Africa. But there is one thing that they do, which maybe is not yet done enough, and it's international collaboration. So you see, there is a lot of benefit in it. It increases visibility, productivity, the impact of your research, and also the research horizon. We heard Prof talking today about trying to interlink aerosols, virus, bacteria into the landscape or biogenic emissions. Those are interdisciplinary topics that can be dealt with. But you can easily do that if you engage in international collaboration. And not just engaging in it, but have a vision in it, have a strategy. So, the first thing I think for any strategy to work in an African context is we need to be original. We need to strive for originality. Originality is what can make us change. So, what is it that I mean originality? Our research needs to be focused on societal and educational needs. We should not do research because it's done in Europe. We should not do research because it's done in Africa or in America. We should do research because we need it. We need to say, for instance, we need to focus on the research maybe on air pollution, maybe on mining, maybe on agriculture, because our people need it. The moment we put originality first, it's easier for us to sustain it because we keep on solving our own problems. So one of the most important strategies that we must understand is originality. We need to be authentic. We need to understand we have different cultural competence. And we need to look at the cultural nuances we have, the distinctions. Maybe in the north, agriculture is different. In the south, you have the ocean. Which type of science can you do to improve the life of the people? And we take the science to the policymakers and tell them and convince them this is what we have to do to change Nigeria. A step like that will be a strategy and will not just be a symposium. Will not just be one project, but it will be a strategy that keeps going. So I think there are a lot of aspects that we can work with. There are a lot of aspects that FOE can go into as a university. Environmental research, where we are, where Prof gave a very good lecture of the various capacities we can go into collaboration. But you have medicinal research, you have agriculture, you have building materials. When I walked around the streets yesterday, I saw the type of houses that are being built. I grew up in Cameroon, and I did my first degree in Cameroon before I left for Germany. And when I come back to Cameroon at times, or even when I go to Namibia or I go to Morocco, Morocco is a bit different, but to Cape Verde, most of the tropical countries, the architecture of the houses have not changed. So the way they build the houses is the same. My father built the house, I lived it. And I asked myself, is it that the education has not reached the people, or do we go to schools just to please some type of sectors? So FOE can go into that. There's just a lot to be done. Building materials, climate research. We see that there are droughts. How can we adapt to it? What can we do to it? It's a lot of things to be done. Air pollution and health. Since we came to Nigeria 3 days ago, we have not seen blue skies. I don't know if you realize that. But maybe it's not an issue because you see it every time. But if you go to a different region, maybe you go to Cape Verde or some African countries, you always have blue skies. So, do we understand why our skies are hazy? Do we understand why people die abruptly? Is it due to the haze or is it due to something we think is spiritual? But I will tell you, there is a lot of evidence that is due to the haze. And this is something that FOE can invest in, or other investors can develop a strategy of understanding and changing. So, we have data centers. Do we know the number of people who are sick of diabetes in Nigeria? Do we know the number of obese people? Do we know the number of people, the number of accidents that happen in our roads? We need data. We need data to be original in our research, to be able to foster, change the life of our people. So we need a strategy on that. So, this is just a tip of the iceberg, but I think you understand with me that there is still a lot to do, and we must start by the originality in our research. So keep originality first, and then there is the adage, necessity is the mother of innovation. When it's necessary, you become creative. And when you keep the necessity first, believe me, FOE will be one of the top universities in Africa in the next 5 years. When you have the idea, you need to have a vision. Vision is not short-term. It's beyond your mandate like an HOD, it's beyond your mandate like a vice chancellor or head of department. It's your mandate to keep it different the way you met it. That's what is a vision. You know, keep it different. I always honor Prof for his vision, because he said he wants to leave the department with something which was different the way he met it. And it's a challenge to all our scientists here and the researchers. Will you leave your department different from the way you met it? And if for that to happen, you need to have a vision. And the vision must not be done by you alone. You can set up a team, and you can have a near real-time goal, an intermediate goal, and a long-term goal. So you must have a goal that is beyond 5 to 6 years if you want to talk of change or you want to engage in a strategy. For a university, you must have that. That's the only way we can empower our research institutions and go back to the top. So, when you have a vision, you have the idea, you have a vision, what should come next? Partnership. We need to seek collaboration. We need to start at home. You need to make small groups within yourselves. That people, not everybody would like to do agriculture, not everybody would like to do geology, not everybody would like to do microbiology, but you always find a few. Don't limit it to FOE. You can go to University of Ilorin, you can make partnerships with University of Ibadan, and you will find some groups. Professor Ulumaide joined our group on African Society on Atmospheric Sciences, because we're just 3 of us who started it, but today we are about 30 members in it. Those were just people in different universities. Our goal is to have 52 members, 1 from each country in Africa, so that we build a small network that we can foster change. But you can start it here. When you have a vision, seek for collaboration. It must not be local. If you want to do atmospheric research, Prof has opened his hands, come to Tropos, so you can have partners. So seeking collaboration should be a way to go. Then, there is another thing that I will come to it. Mentoring. Nigeria has a very big diaspora. Don't forget, you can also collaborate with the diaspora. I know of colleagues with whom we studied, they are professors, they are medical doctors, and they strive for networks where they can contribute backward. So, don't be shy to contact them. They can help in seeking and linking you into different type of research. Now you have a partner, you have a network, so you need to go to the next step. I would say this is one of the difficult parts in Africa as a whole, having funding. You need money to do research, so you need to have some funding to go about it. Not every country is rich. South Africa is top in research because they have a bit more, they dedicate more than 1% of their gross domestic product to research, and then they can keep going. But not all African countries do that. So it's important for a young university like FOE, for young scientists like you, to have a different strategy. How do you get to funding to pursue your quest for research? I would say that you should engage in developing funding calls. You should engage with the Nigerian funding agencies, talk with the people there, talk with the politicians, participate in their workshop, make your voices to be heard, so that if they don't put the type of research that interests you this year, they will think about it next year. You should have a long-term strategy. A strategy should be beyond 2 or 3 years. You need to know where you want to go to, otherwise you stop. Because this year, atmospheric chemistry was not part of the funding, or agriculture was not part of the funding. So please keep a vision, talk with them. In Europe, it's not so much different. If we want a big project to be done, we go to the ministry, we talk with the ministries, we tell them that this is important, and within some time, they make funding for it. It's a strategy we do, and it's a strategy that can work for you. So, make use of the diaspora. Here I have a small statistics of the amount of money that comes into Nigeria from the diaspora and the different countries where the money is sent. So you can see Nigeria has a very big diaspora. And this is the amount of money that comes from the diaspora to Nigeria per year. That's 42 billion naira.
Dollars.
So that is 42 billion naira. It means if the National Research Foundation in Nigeria cannot support your research goals, the diaspora can do it for you. You can make use of the diaspora. They have a lot of potential, and that's why you need to talk with them, engage in networks. It should be a strategy to engage with them. Write to 1 or 2 Nigerian groups abroad. If you have an idea, write to them. Tell them what you want to do. Tell them you are part of the university, because there are a lot of fraudsters. People just want to misuse funds. But I am in some groups that if they know you really need it, they will give it to you. So make use of the diaspora, and not just for the money. They can help in mentoring. You know, we have a cardiac society that cardiac society of Nigerian experts. If you have a cardiac problem, you write to them. Maybe some of them maybe come once a year to some type of project. They can help you, and they have other engineering networks. You can write to them and tell them this is your problem, and they can help you. So they can mentor you, and they can actually help in funding your ambitions. So make the strategy, collaborate, communicate. So one of the last things that I was asked to talk about is the equitable partnership. So it's normal that most countries in the South, they would like to have equitable partnership with institutes in the North, but equitability needs to come with a certain strategy. You cannot do research that is developed in Europe all the time and you want equitability. You know, Europe cannot always fund all the projects and you want equitability. Because as I said, the funding is always necessity driven. So for you to get the funding, you need to just align with the funding philosophy of the founder. You need to do what you want it to do. And those who decide what you want it to be done are those who want to solve some problems. So, to have a equitable partnership, you need to be non-reliant. So you need to be original. You need to say, this is a Nigerian problem, we need help, we need partnership. So somebody will give you because he wants you to collaborate, not because he wants you to do what they want you to do. So a critical partnership starts with originality. And you need to be able to take leadership position. You need to say, now I want to behind this project, I want to be the leading investigator because this is something that concerns us. You need to go to four corners. The chief investigator, the main scientist must not be from the north. It can come from you. So know that if you have capability, you should be ready to take leadership. You should be ready to take responsibility. You should be able to have structures. I don't know how financial structures are great. So you need to have a financial and administrative structure to receive money. How it should be divided. It should not be coming to my pocket or going to your pocket. It should be for a goal. And the goal is beyond your tenure. Like that, you can actually believe that even predictability is just to enrich one person, it will not work. So a critical partnership needs to be mutual. And don't forget, you need to try to leave behind. Leaving behind is something that it's sympathetic to any donor if he knows you want to leave behind something. Bill Gates Foundation is a good example. You can have some millions of naira if you have a good project, you can go to them. So, as Prof. Herman gave you some insights, we have a collaboration with Cabo Verde, when the president of Germany and the president of Cape Verde inaugurated our station last 2 years ago. And we came there because some people had a vision. They had a vision to investigate ocean atmosphere interaction. And this is an example of how sustainable partnership works. The strategy was look for an idea, partnership with some people, make it equitable, having a win-win, and then you look at the future. And that's how it works. So I will not go through it, but the point is that it's been a success story. There has been a collaboration of the local institutions and three institutions from two institutions from Germany and one from the UK. And through that we have a memorandum of understanding. We developed infrastructure, we encourage capacity building, and we have had a lot of publications, just in our group more than 20, and in the other groups almost more than 6. So you can see we will increase the visibility of the local scientists when we do that. This is just some insights from the infrastructure that we are building there. I will not go into it, but you can talk more about it. So I wanted to end with one or two examples. Going around, as I said, I didn't see a blue sky. And I said, if somebody here wants to work in the research of air quality, what would he do? What should be the strategy to follow? So I would say he needs to focus on the research agenda. You need to say you want to do in or outdoor pollution, because each of them need different type of instrumentation, different type of infrastructure. You should start with one. You need to build an interdisciplinary network around you. Atmospheric research is no more for chemists. You have physicists, you have microbiologists into it, you have geologists into it, and you have a lot of health personnel, epidemiologists, so risk assessment. So you have a lot of people into it. So develop a small interdisciplinary network. Start collecting some data. If you don't have collectors, you can use satellite data sets. You can go into local sensors to have a quick look. Then you can look for partners. Tropos is ready to partner with you. But it's not only Trumpers. You can also have other partners in the US. You can have partners in the UK. And then you can then look for the question. Is it these emissions that's your problem, or is this these emissions that's your problem? And together you people can develop grants, get funding, and then do the research. So, I hope within this time I've been able to give you an overview of how a strategy should look like. And I just summarize my talk with this image to give you the small foundations that you have to think about if you want to develop a strategy for strengthening collaboration and having equitable partnership. And I thank you for listening so well, and if there is any question, I'm ready to take it.
Thank you very much, Professor Fonda. So the floor is open. We want to entertain a few questions, written or spoken. Questions, please.
Be able to, I want to ask a question.
Good afternoon, Prof.
Is a live video, you understand?
Greatly impressed and I'm happy to listen to you for this collaboration. Let me have sought for collaborations, that number, where it was not company.
It's
And just give it. Let me see. Also tell us how you persist to get a collaboration. Now, in the show of I'm very careful. How do mathematics? I just want to know how do we mathematics partake in particularly research? Your simulations, your data, how do you analyze them? Are you doing the role of mathematics?
Thank you, Prof. for question. I would like to say that mathematics is one of the core in all sciences. So to have good network, to have societal impact, I always underline the word societal impact. We should think of research that will change our lives. Not research that is good for the textbook that nobody will use. We need to do research that will change our lives. And in that, we need models. We need models to be able to predict, to change. How do we do it? And mathematics is one of the cornerstones of such models. There have been projects that have been involved with epidemiologists, health effects, trying to factor how Hamatan affects some type of respiratory diseases. And the person who is there doing all the correlations for us, using different type of models, is a mathematician. So we need mathematics a lot. We need to talk to each other. And I know when I grew up, I did some physics, and we thought doing physics, you don't need to talk to chemists. So and then I went to Germany, it was even worse. The physicists, they think the chemists they don't know anything, and the chemists they think the physicists are stupid. So everybody keep thinking it's better. But the good news is that after some years, science has evolved, and everybody knows that it's only interdisciplinary that can change our lives. The time that we look at science to be mathematics or physics is gone. So to have an impact to the society, we need to reach out to the social science. We should not stay in the classrooms on our computer. We need to talk to the people, talk to the farmers, talk to the herbalists, because yesterday we were at a certain spring. I don't know the name. Ikogosi, and the lady there was giving us the myth behind Ikogosi, and she said it dates back 700 years ago. So that information has been passed by generation to generation. And nowadays, if you go there, if nobody told you that there's information that was passed, you will not know that there were people who understood science 700 years back. But because maybe the science we have done, we are doing now, we don't look at what we have, how we can improve it. We always believe the science we need to do should be that reflective of the norm. But I was very happy when I listened that there has been transition of knowledge over such a long time. So it's not only the mathematicians and the chemists that we need. We need those people to be able to change our lives. So I can say, Paul, you are in the center of interdisciplinarity. You need to open your hands so that people to come to you. You need to make some meetings so that you become the center of it. Because without mathematics, all of us are done.
Well, let me chip in one or two things. So directly, you know, we have quality monitoring. We are much interested in discussion of the pollutants. So, yeah, the fate after some time, that is where mathematics comes in, like the Gaussian equation and also the hammer. We apply them to the movement of the pollutant from one place to another.
Thank you very much, Professor Limoli. I have two questions here. Is Scopus open for international internship fellowship and master's programs? Is there a 100% funded scholarship for master's students in Germany or in Scopus?
I think that one I can allow Prof to support me, but the one I'm not aware of is a 100% scholarship. I know DAD gives 100% scholarship for master's program if you're coming from a ministry. So if you're working within government spheres or you're working in an institution, you can take a sabbatical and you can be funded by DAD. But within Tropos, I don't know. I don't know if Prof knows it.
We do this from time to time, but it's honestly a little bit limited. Yeah. We cannot accommodate many master students and take the support from our internal funds. We don't have really a program for this, but on the basis from time to time to start, there's a master applicant coming up. I think that should be possible. This can be done by the resources of the departments. I served on some panels of the DAAD, and what Inga says, if you want to apply for a DAAD fellowship, it's very big proposal, even if you come to Germany for 3 months. It's like a research project. Yeah. So the proposal writing takes more than 3 months if you ask me, to get the money. So it's a little bit, let me say, crazy. They need to be straightened out a little bit. So I would rate this ineffective if you really write such a proposal for half year and then comes 3 months. We will try to support. We should also search, like Madhuga said, for some funding mechanisms where we get some third-party support to support both of us, you and us also.
Thank you very much. I think this will be the last meeting question, and perhaps I'll take just one more spoken question. Is there a model for health risk assessment of PM10 and PM25? Sorry, my glasses are feeling 2.5. If yes, how can we go about it? Then how can we connect to the diaspora funding?
Yes, there are different models for PM 2.5 and PM 10 discussion. Those are discussion models. There are even websites that you can look at. So nowadays, there are low-cost sensor networks from different companies that they have monitors used throughout the world, and based on the input and the wind fields, the meteorology, they make models how the PM 2.5 and PM 10 changes all the time. So I think Google will be coming out with one. Very soon, already if you go to windy.com, you can there see what's the PM 2.5 and PM 10 in your environment. It's a model, but they are trying to always improve it when they have to. The other question was how can we link the diaspora? I think there are a lot of diaspora network. The best thing is to ask your embassy. So if you want to, you can write and go to the embassy website. You have different groups at the embassies, like you go to Nigerian embassy in Germany, or you go to Nigerian embassy in the US, you see those groups that are registered there. They are also co-funded by the Nigerian government, so we have funding. If they have some aspects in Nigeria from the government, and they have funding from the US or from the German government, and those groups you can target them for very good projects. I think it should be good to then make a move, because there is always mistrust when you don't know who you're giving money to. So I think where like an institute should take that as a strategy. If you want to contact them, you need to go through some channels so that they know this is serious application and not an application for somebody that will never trace what you do before. If you need help, you can always write to me.
Thank you very much. If you need help, you can always write to me.
Standing on existing protocol, thanks to Professor Dr. Aman and Professor Dr. Wadunga for a fantastic and thought-provoking presentation. And like you said in your presentation, originality is key in our research, and we should make it local in order to solve particular problems that are peculiar to us here. But the area where we are lacking in Africa is basic experimentation and recent equipment and machine for characterization of maybe air quality, water quality, or whatsoever. Because in order to publish in high impact ranking journals, we need all these characterization. I don't know if any way Chopos can be of help in equipping our laboratory at least to a certain standard. Thank you.
Yes, I think there are different avenues of equipment, not limited to truckers. I think Germany does a lot with that. I know of a couple of hospitals that have been equipped by different projects, German projects. There are funding projects that you can actually apply to. You need to look for partners. You can support if it is a joint project. You can give the German host for such a project. If you know we need to acquire such an instrument in such a lab. But there are such governmental, developmental projects that you can engage in, which is beyond what purpose to say you will do like an institute like one. Where you'll be connected to many instruments, to many avenues. And I think there are also foundations in the US that sponsor instrumentation. So we had an air quality workshop where we were in contact with different donors, and they did not say they did not sponsor, but they always want to see the necessity for it. Because some of those instruments cost €1 million, some are 500,000 euros. So if you do the math, it's quite from billions of naira. So you need to be able to make a proposal that will be sustainable so that they can fund it. So there are avenues to fund it, which is beyond purpose, and it's just to look into the costs. And I can share the slides with you. There are some funding agencies that fund instrumentation. That would be careful, but I can give the mic to Prof if you have something to add. Okay. So Prof, that's what
I said, one of the last question, let's entertain your question. Yes, yes, yeah.
Thank you very much for that question. My question is on the question. I should like to ask you guys a very important question. So, yeah, some cities, the organization was definition. People are going to different cities where they have different factors and different solutions. Like, for example, I saw a video on Instagram, and I was in India. They don't have much things and proper definition. And yeah, I saw that it's like most of the periods, the city economic index used to reach which is an alarming level, and to promote different kind of air population. So now my question now is that what are the factors or like still reasons why some certain cities or some certain countries experience loss population rather than without even having this factor? I don't feel like it's
Okay, thank you for the question. I think part of the students take the lecture. So maybe that's opportunity to come to the next week lecture. Because we will go into that later. So not to tell you everything so that you should not come to the lecture, I will just summarize the answer. So meteorology is one factor. So if you have strong winds, it plays a role. If you have a lot of if you have rain, haziness, like now it's hazy, you have no rains. If the rains come, maybe you see a blue sky. So meteorology plays a role. Another thing is topography. The geology plays a role. So in some cities, they are in the valley. So when they are in the valleys, you have something we call inversion. And if you have inversion during this time, everything is trapped. So if you have, they say warm air rises, right? And cold air sinks. But what happens if above you is warm and you are eating? The winds will not go above. So you be like in a blanket. So then in the valleys, those type of situation, the topography can lead to enhancement of the pollutants. We still have emissions and traffic and urban pollution is different from cities to cities, county to county, the type of cars you use, is the diesel power, automobile power, so you need to come to the lecture. Okay?
Thank you very much. Distinguished ladies and gentlemen, this brings us to the end of this symposium. But before we call it a wrap, I would like to invite the head of the department of chemistry, who essentially is the brain behind all of this, to come and have some closing remarks. Thank you.
Thank you very much, sir. First of all, I want to thank Professor Haman, who has been teaching for 3 hours. We appreciate this. All of us appreciate your passion and athlete development nations. All has a very strong passion for athlete development nations. Most of that come to mind. Because of that, we have a station in Cambridge. I'm going to like 15 years, close to 20 years now. Also in Namibia, Morocco, and now is in Nigeria. Well, my prayer is this, that what you have done, Cambridge, you have one in Nigeria. Thank you very much, sir. Professor Wadinga, thank you very much for the presentation. I want to also thank our mommy, who has us, Professor Ramoli, and everyone, but I don't want to give both of thanks because we have our Professor Bolari who will do that. But I want to appreciate everyone for me. God bless you, Prof. You're welcome to give the thanks to them on the last session.
Good day, everyone. On behalf of the Vice Chancellor of this great university, Professor Sophia Akoyabu, I say thank you for this great opportunity
And for this symposium, it was an eye-opener. Because as a person, I sat down here carefully and listened attentively, and I could see different opportunities I can explore too. And I expect that everyone here also gets something tangible. So I want to thank you for this symposium. I want to have more of it. I'm sure that the university will gain enormously from your wealth of experience. So really thank you, Professor, and two distinguished Professor Ham and the family. You are much welcome. And for everyone that's here, both students and the staff, I want to appreciate you. It will be so funny if you organize such a symposium like this and the symposium. And from the discussion today, I wish there's going to be a good research that will deal with our environment. Our environment is so terrible all over Nigeria today. And we are walking around the clock and it will not be like that in this university. Go everywhere, see everywhere, literally with all kinds of things. And I felt that this environmental culture we're having everywhere will definitely affect our atmospheric condition, whether we like it or not. So I think that's another area that some people should need to look at. If you get to this place on Sunday, the environment was so terribly lit up. I have to talk with the Vice Chancellor of the night. We can't keep it like this. And I made sure by the time it was 7 a.m., the environment was clean up. But never the after that they cleaned up. Where was it deposited? How was it treated? I don't know. But I think as researchers, we can work on the environment to make living a worthwhile. So thank you so much. Dear distinguished professors, you are welcome. God bless you. And we'll get back soon. Thank you.
Thank you very much, Professor Dolari, for the vote of thanks on behalf of the Vice Chancellor. When we started this program, I said we have a wonderful woman whose efforts built this edifice in less than 6 months, and who happens to be one of the hosts. And she has some gifts for our guests. So I'll be inviting Professor Mrs. Biawe to make a presentation on behalf of National Conference Center and perhaps on behalf of the university. You're welcome.
Once again, everybody, professors, we're very, very happy to have you around. It's a gift from the center on behalf of the Vice Chancellor, but inside that bag, images of the university as well as the images of the future university that we dream of. You will be looking at documents that showed what we want our laboratory to look like in the nearest future. I saw what you showed us here in the challenge. You will also be finding out, like you were saying, with the help of all of these individuals, we are not relying on government alone, because we know government cannot do it all by themselves. We are looking up to people from the Directorate of Advancement, individuals, other countries, that can invest in our university. For instance, we want to believe that at one time or the other, there are reasons for you to donate equipment to the Department of Chemistry, perhaps other departments. I was in the University of Houston, Texas, Southern University, and upon new supplies of equipment, I found some of the equipment that I was using in the laboratory very effective. But my host said, for the reasons of having them in good packets, including nano, thermal material, you can have this for your laboratory. And I tell you, up until this, some of the equipment that was given to us, people believe that it's because it is spent or useless. In the UK or US, no. Sometimes it is because by the virtue of new of new, not just technology, new budgeting and re-equipping the laboratories, we discovered that we can have extra microscope, binoculars, probably pending ones have just been delivered, and in the year 2023, you had 5 purchased from the research grants. So some of this can come in excess in some of the laboratories to proceed. I want to let you know that once you have such, we don't take up some equipment or functional equipment that apparently probably have been replaced and you have them in excess. We will look forward to saying that troops have donated substances to our chemistry department, microbiology department, soil science department, and so on and so forth. And they will still be very, very effective and useful. There are many ways to continue to improve our own environment. I heard Professor Bolan talking about tidying up. So many things can be done. So besides this being a reminder of the fact that we came to Functional Center, a center that was built by what I call OPM, other people's money. It isn't money from government, it's not money from the university, but the kind gesture of some goodwill individual outside the university and from within. We have this place to present you. And we are still looking forward to having not just buildings, like I said, equipment, all things that can be useful for our researchers. We also can travel this. And then we come back so that research can be a continuum. On this note, once again, we have enjoyed you, we've heard you, we've seen opportunities where we can collaborate. But we also want to make this place a place where you can really come down, stay the next 3-4 months, and you are not idle. You can work in our laboratories too, because we have been fully equipped. Thank you very much. God bless you as I call you forward to take this small part.
Yeah, thank you. Very good. Yeah, thank you. Thank you very much.
Thank you very much. English Professor Yahweh. Ladies and gentlemen, that is the end of this speech. And we will just have group photographs with our guests. Thank you very much. I didn't tell you my name, I'm actually
Now, guys, and I think we need a call. You want to substitute this.